Hello again. Welcome to Quifitech Lab. In this video we will continue with the lab from previous video. Recently, we have designed the network topology and implemented access layer configurations, which includes host names, login security, passwords encryption, VLANs, DHCP pool on the DHCP server and allowed site A VLANs on aggregation layer. ISP router have 3 connected serial interfaces. Serial 3/0 have an IP address of 10.10.10.2 with a subnet mask of 255.255.255.252. Description link to head office router. While on Serial 6/0 the interface have an IP address of 10.10.10.5 with a subnet mask of 255.255.255.252. Description link it to Site B router. Lastly on Serial 2/0G interface have assigned with an IP address of 10.10.10.9 with a subnet mask of 255.255.255.252 as labeled. So the description link to Site A router. On head office router we have 2 directly connected interfaces, FA0/0 to local network and Serial 2/0 to WAN. So we have Serial 2/0 interface assigned with IP address 10.10.10.1 with subnet mask of 255.255.255.252. We also have Fast Ethernet 0/0 interface assigned with 172.16.0.1 with a subnet mask of 255.255.0.0 as a result of IPv4 Class B. Site A also 3 directly connected interfaces. Serial 2/0 assigned with IP address of 10.10.10.10 with a subnet mask of 255.255.255.252. Description link to ISP router. Interface Fast Ethernet 0/0 assigned with IP address of 50.50.50.2 with subnet mask of 255.255.255.252. Description link to multi-layer switch 1. Then we have interface Fast Ethernet 1/0 assigned with an IP address of 50.50.50.6 with a subnet mask of 255.255.255.252. Description link to multi-layer switch 2. Well, what about Site B? We will configure a router on stick where interVLANs connected to a switch via one cable. Let's then configure routing protocol OSPF 10. 10 means the process ID, starting from Site A router. To enable routing on this router, we type the command router OSPF 10 on a global config mode. We then specify the router ID, which could be any number ranging from 0 to 255. On OSPF, when the router ID is not manually configured or when the loopback interface is not configured with an IP address, then the router will have to use the highest IP address assigned to a directly connected interface. Well, when there are several interface loopback configured, then the router will auto-select the highest loopback as its router ID. Well, in this lab we will assign router IDs manually. After giving router ID, we have to list all the network IDs for directly connected interfaces on that router followed by wildcard mask and area number. The wildcard mask is used on OSPF and access list. The easy way to cheat correctly, you can assume subnet mask of 255.255.255.255 and then you can start subtracting the subnet mask of those directly connected networks from this imaginary mask of 255.255.255.255. For instance 10.10.10.0 belongs to subnet mask of 255.255.255.252 according to /30 subnetting. Which means to find a wildcard of this network, we have to subtract 255 to 255, we have first 0, and then another 255 to 255, we have another 0. For the third octet or decimal, in this case, it's also 255 to 255, we will have another 0, and then last decimal is also 255 to 252, which is then 3. Then we have our wildcard mask of 0.0.0.3. We will configure OSPF routing protocol in all the layer 3 device on this topology. The configuration is the same as the network advertised on OSPF routers on normal area. So on Site A there are 3 network advertised. It's 10.10.10.8, then it's 50.50.50.0 and 50.50.50.4. On head office OSPF router there are 2 network to be advertised. It's 10.10.10.0 with wildcard mask of 0.0.0.3 and 172.16.0.0 with wildcard mask 0.0.255.255.
The adjacency will be established in connected neighbors, then they can exchange routes. This means that Connect OSPF routers would flood link state advertisement between each other and create adjacencies with another. ISP router have 3 OSPF neighbors, so this means there are 3 network to be advertised, which is 10.10.10.0, also 10.10.10.4 and 10.10.10.8 with wildcard mask and area numbers. What about Site B? As we have mentioned earlier on, that router on stick means we have to advertise all subnets available for VLANs. Okay. Okay, let us configure interfaces for this local area network. What you need to remember is that when you have VLANs configured on a switch and when that router is directly connected to a router, it means that the traffic from the switch to the router will be tagged as it carries the traffic that belongs to different VLANs. So on that interface connected from switch to a router, it must be configured as trunk, whereas the rest of interfaces are atches. We already configured the switches for this site on a previous video, so we have to assign the IP addresses to sub-interfaces. To do this, we type interface port number.vlan number that you want to assign IP address on. In this case, we have selected int fa0/0.70. The following command is encapsulation.1q70, and then we can assign the IP address with its subnet mask. In this case, it is IP at 192.168.2.125.255.255.224. Someone may ask why .224? Well, it's the subnet mask after subnetting.
So it means we have logical subdivided the IP network with a goal of splitting a large network into groups of smaller interconnected networks to minimize traffic to flow to unnecessary routes. So we will configure the interface fast Ethernet 1/0.80 or .90 and 100 the same way. For this site we could have had a dedicated DHCP server. However, we gonna use service DHCP on router. The first thing to understand is that we are willing to allow all in-host devices to assign dynamically IP addresses. Why is that? Because it is the best way than to assign static IP on each devices. Imagine how long would it take to assign static IP address for 512 host devices manually. Well, let's dive into it. It is good to let the router alert that we are now configure service DHCP by typing command service DHCP. Not always compulsory for the routers, but for layer 3 switches, it is. Well, get on it. IP DHCP pool name, where name could be any preference. In this lab we gonna use pool names as the name of VLANs we creating pool for. We then have to type command network, which is the network ID with mask of that subnet. After these commands you can now navigate to network adapter settings and select DHCP. Here we go, all the end hosts have leased with dynamic IP addresses. There are access points introduced on this lab, however we won't dive deeper on them in this lab. But on upcoming videos we will introduce wireless LAN controller. So the configuration for now is to give a name to SSID and select authentication type, then create password for wireless clients. On Site B, we have TCP connection on, FTP and HTTP services. So this means servers also must have static IP addresses configured, and also these services must be enabled. Well, we will further configure who can access these services when we introduce extended access list. Let's dive into multi-layer switches. Remember that we have already configured VLANs allowed and interfaces, so we didn't configure OSPF routing, which is very important so that these devices will also form adjacency with OSPF router site A. Again, when we enabling routing on layer 3 switches, we type the command IP routing, then we can proceed with normal way of configuring OSPF routing on multi-layer switch 1. We have to advertise the network 50.50.50.0, and it is very important to not forget to advertise the subnets of the traffic passes through each trunk interface connected to each switch. So this means we have to advertise network 192.168.1.0 up to network 192.168.1.160. What we did on this multi-layer switch 1, it is exactly as what we gonna be doing on multi-layer switch 2. And we have also introduced default routing towards the next hop FA0/0 from multi-layer switch 1 and FA1/0 from multi-layer switch 2. We do this so that the packet will be sent if no specific router for the destination network is listed in the routing table. So if there is no default route set, the router will discard all packets with the destination address not found on the routing table. Well, don't leave it behind. Maybe you can also configure static routes, but for now we gonna use dynamic routing. Remember, when you have to assign the IP address on the multi-layer switch, you have to select that interface and then execute the command no switch port. Okay, finally let's configure interVLANs routing. This is the ability to route or to send traffic between VLANs that are normally blocked by default. We must keep in mind that, although switches and VLANs work at the MAC address layer 2, traffic cannot be routed between VLANs at layer 2, so it is only possible in layer 3. Let's continue. To configure inter-VLANs, we use the command interface VLAN followed by a VLAN number we willing to assign IP addresses to. This command is executable on global config mode. We further type an IP helper address followed by the IP address of DHCP server we configured not so long ago. So ever since we have DHCP pool, so all their intervlans will have same IP helper address. We finally assign the IP address of the default gateway we specified on each pool. Well, the configuration is the same for all inter-VLANs from 10, 20, 30, 40, 50, and 60. Also, multi-layer switch 2 will have the same configuration as multi-layer switch 1.
Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves, there's no one I can turn to. And I know all the feelings that we shared are in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. We're moving on. I know times are
We will talk about voice VLAN later on, because this lab, we didn't use the router 2811, so telephony service might give us an issue for now, but we will configure it later on. Although the head office appears small, it doesn't matter. What matters is that the end host devices on the network can communicate internally and also externally whenever needed. Okay, let's configure IP DHCP pool for this local area network. So we have a network ID 172.16.0.0 which belongs to class B IP address with the subnet mask of 255.255.0.0, where the first usable IP is 172.16.0.1 and the last usable is 172.16.255.254. Head office can have multiple end host devices, or even a data center. They can also have subnets. They can have cloud-based network infrastructure. So we will just use these two on-premises servers FTP and web. It could have been DHCP, DNS, IoT or TFTP or maybe mail server or even NTP and syslog server. So we will talk about that on upcoming videos. Well, time for testing if all these devices can communicate. How do we test that? Well, let's first verify if DHCP is enabled to clients and they can dynamically assign IP address list. Well, they do. Now we can send those ICMP echo requests to ping any IP address on the network. Surely we will get replies. Or maybe traceroute to find out the reachability with number of hops. Well, I'll just send Ethernet frame from particular source towards particular destination. It all went successfully. So again, as a result of long video, we have to introduce access list. We can choose between N80 or PAT, and then we can further ensure SSH is configured well on layer 3 devices and layer 2 devices. We can also configure switch port security. We can shut down all unused ports or put them on black hole VLAN. Then we can test everything once more. I believe this video have come to an end. I hope all this was informative. Again, thank you very much for watching. Please, if you haven't watched the previous video, you can search for it. Make sure you like, share and subscribe and click the notification bell to our channel Requsted Lab. I hope to see you on the upcoming video.